And we're going to be looking at exponential functions. So the variable is going to be on the exponent. First of all, let me graph. I'm going to come out with values of x's and y. I'm going to think of random numbers of x. Let's say -2, -1, 0, 1, and 2. So if x equals -2, I have the function 2, -2. I know 2 to the second is 4, but 2 to the -2 gives me 1/4. Remember, the negative exponent just makes it a fraction. If x equals -1, I have 2 to the -1. I know 2 to the 1 is 2, so 2 to the -1 will be a fraction, 1/2. Then I have 2 to the 0, as any value other than 0, any value to the 0 powered is 1. Then I have 2 to the 1, and then I have 2 to the 2. That basically gave me some points, -2, 1/4, that's 1 point. Then I have the coordinates -1, 1/2, the 0.01, the 0.12, and the 0.24. I plot my points, and there you go. See, I have -2, 1/4 right here, -1, 1/2. It seems like my function from left to right, my graph is growing up. Now let's take a look at this one. I'm going to think of x and y values. Let's say I think of -2, -1, 0, 1, and 2. So if x equals -2, I have 1/2 to the -2. First of all, I think of 1 to the second. I'm going to square everything. So 1/2 squared is 1/4, because 1 squared, 2 squared. But because it's to the -2nd, 1/4, I'm going to flip it as 4/1, better known as 4. That gives me a coordinate, -2, 4. Now I'm thinking, what if x equals -1? -1/2 to the -1, that gives me 2/1, better known as 2. Now, what if I have 1/2 to the 0? Well, it's 0 power, so it's 1. What if I have 1/2 to the 1? That's 1/2. And then 1/2 to the second is 1/4. So these are the points that we have. It looks like my graph is going down. One thing though, the base, this is going to be important. On exponents, when the base it's a positive value, but more than 1, so it's a positive value more than 1, we're going to get our function growing up. We see an example there. If the base is a positive value less than 1, we're going to see the graph is going down. The nice thing on both is the y-intercept. So on the y-axis, I'm always going to cross it at 1. So taking a look at this one, my base is more than 1, so I expect it to go up, and it should look like this. Now we're going to learn how to solve for exponents. Now, if I was to able to write 27 as 9 to the something, then I know what x is. But unfortunately, I cannot. So at this point, what we want to do, we want to have the same base. 27, I can write this as 3 to the third. That's 27. So 9, I'm going to write it using the same base. I'm going to write this as 3 squared. That's 9 to the x. So once again, I want the same base. I know on the left side, when I have parentheses, I have to multiply my exponents. So I have 3 to the 2x is equal to the 3 to the third. Now that I have the same base, I'm going to let the exponents equal each other. So I'm going to say that 2x is equal to 3. I'm just looking at the exponents and solve for x. Divide both sides by 2. So x is equal to 3 halves. If you guys like decimals, that's 1.5. Looking at this other one, I want to write everything on the same base. 16, I can write that as 4 to the second. So I'm going to leave the left side alone. So I have 4 to the 3x minus 1 is equal to 4 squared, because I'm going to write, that's how I'm going to write 16, to the x plus 2. Now I have that 4 to the 3x minus 1 is equal to 4 to the 2x plus 4. Notice I had to distribute my 2 because I'm multiplying my exponents. Now that I have the same base, I'm going to let my exponents equal each other. 3x minus 1 is equal to 2x plus 4. Solve for x. I'm going to subtract the 2x. I'm going to add a 1. So I get that 1x is equal to 5. Now let's take a look at example B. I know 6 to the third is equal to 216. But now I want it as a fraction, and then the 216 at the bottom. So I'm going to rewrite this. Once again, I know 6 to the third is 216. So I want the reciprocal. So I'm going to say 6 to the negative third. So I have that 6 to the x is equal to the 6 to the negative third. Now that I have the same base, I'm going to let the exponents equal each other. And I'm just going to write x equals negative 3. That's done. Now here, I have 2 to the third is equal to x. So I want to write this as 2 to the third as well. 2 over 3. 2 over 3 to the power. So it seems like 2 squared gives me 4. 3 squared gives me 9. So it seems like I'm going to use the second power. But I want the reciprocal of it. Because instead of 4 over 9, I'm getting 9 over 4. So I'm going to use that. Now that I have the same base, let the exponents equal each other. X equals negative 2. Get the same base, and then let the exponents equal each other.